This is what your Go code looks like without interfaces, rigid and inflexible. And this is what it looks like with interfaces, clean and scalable. In today's video, we'll break down interfaces in GoLang, why they matter, and how they can make your programs cleaner, more maintainable, and scalable. If you want to write efficient Go code, mastering interfaces is key. Let's get started. In Go, an interface is a type that specifies a set of method signatures. Any type that implements those methods automatically satisfies the interface. This allows for flexible and decoupled code because different types can implement the same interface. Here's a simple example. We define a speaker interface that requires a speak method. Both dog and cat implement the speak method. In the main function, we create a variable of type speaker and assign it either a dog or a cat, and it calls the appropriate speak method for each. So, why use interfaces in Go? Flexibility. You can write functions that work with any type as long as it implements the interface. Decoupling. Interfaces separate what your program does from how it's done, making it easy to swap implementations without breaking the rest of your code. Testability. Interfaces make it easier to test your code by allowing you to use mock types that implement the interface during testing. Imagine you're building a payment system that needs to process payments from different providers like PayPal, Stripe, or even bank transfers. Instead of writing separate functions for each provider, you can define a payment processor interface and let each provider implement it. Here's how that looks. The payment processor interface defines a process payment method. Both PayPal and Stripe implement this method differently. The make payment function accepts any payment processor, so you can easily switch between PayPal and Stripe without changing the rest of your code. Go also has something called the empty interface, written as interface empty curly braces. The empty interface can represent any type, because every type implements the empty interface by default. This is useful when you need to handle unknown types, but it comes with trade-offs like losing type safety. Here's a quick example. The printAnything function accepts a parameter of type interface, meaning it can take any type of input, integers, strings, booleans, and more. This is handy when you need to work with unknown types but should be used with caution, as it removes type safety. Here are a few best practices when working with interfaces in Go. 1. Use small interfaces. A good interface typically contains one or two methods. Large interfaces can become hard to implement and maintain. 2. Don't overuse empty interfaces. While empty interface is flexible, it sacrifices type safety. Use it sparingly when handling truly unknown types. 3. Design by behavior. Focus on what a type does, not what it is. This allows your program to be more flexible and decoupled. And that's a wrap. Now you understand how interfaces in GoLang can make your programs more flexible, decoupled, and easier to maintain. By using interfaces effectively, you can write reusable code that adapts to different implementations seamlessly. If you're interested in learning more, check out our previous video on context in GoLang to understand how to manage timeouts and cancellations efficiently. Don't forget to subscribe for more GoLang tutorials. Happy coding!